Let's continue then with the exercise, part 2, the analysis of satellite data, Sentinel-2 data. For this we're going to use another built-in tool, and we're going to perform an analysis of several bands of data. Just quickly go back to the instructions and look at what it is we're going to be doing. Because the satellite image contains several bands of data. Like the aerial photograph we looked at, we had the blue, the green, the red, and the infrared, stored in 2 separate images. What we're going to have now, from Sentinel-2, we actually get this sort of violet light, far end blue, which we're not going to be using. That we can ignore. But we get all of this, we get all of these bands. This is something we can ignore as well. We're going to be using this band 8 rather than band 8A. And then we get bands 9, 10. We get lots more information. And each of these bands, they're stored as grayscale data, and which means it goes from 0 to some maximum value. And each of these we can interpret as being an axis on a graph or a plot. So we can actually have multi-dimensional space, not just 2 or 3, but we can have, in this case, we've got 12 bands of data, 12-dimensional space. You can't imagine it in your head, but mathematically perfectly doable. And so we can plot the value of each pixel, the strength of the light in each band into this multi-dimensional space, and then we can start looking for scrolling down here, we can start looking for these sorts of clusters. So here we just have red and infrared, but if we extend this out to multi-dimensional space, we can find where we have pixels that have similar colors. And we're not talking about where they are in the image, just what they look like as individuals, what their particular qualities are in the electromagnetic spectrum. And if they look similar, if they have a similar spectrum, then they are probably of a similar type, and we will call them that. So how do we do this? Well, the first thing to do is to actually get the data into the project. So let's go back to our project. Here we've still got I've got the infrared file here, turned it off, but I've now got the RGB file here, and we're going to keep that in just because we want to perform a quick check in a minute. We'll go to catalog, hopefully at some point. There we go, and we want to go to the ESA folder, and then we want to look in this this folder here, and take in this resampled nearest neighbor clipped image. Drag that into the project. So it's a nearest neighbor resampled clipped image. Clipped because the original satellite image was much larger even than this. We can see that this is considerably larger than the aerial photograph, and this was actually compiled of 2 different images. This is a clipped version of the original satellite data image. So they are really quite large and contain many bands of data. So it's quite a large data set to work with, which is why I've cut it down, clipped it for you, so that your computer isn't being overloaded with too much data to work with, especially over the network. Otherwise, we probably wouldn't do this clipping, depending on what our aim is. But the reason I've left this RGB and the aerial photograph in there is because we need to check something out. If we zoom in here to, say, an edge like this, we can see that it's a much lower resolution in the satellite image in comparison to the aerial photograph. You can see that quite clearly. But there's also something else a little odd going on here. If we turn off this image, look at this area here with these nice red tiled roofs, and in our satellite image they're blue. So that's not quite right. We've got a problem there with the data. Well, what is the problem? If we go back to catalog and we try and open the metadata for this, view metadata, and here it is. Here's our metadata for this, and I've written this in when I did after I did the resampling. This is not a default thing that comes about, unfortunately. But reading in the metadata, just trust me on this one. Raster band 1, this was referring to our current image, the one we're seeing. Band 1 is Sentinel-2 band 2. The raster band in our current image number 2 is Sentinel-2 band 3. Right, so this first band, band 1, the key color should be blue. But when we look here, band 1 is red. So I think we can pretty much see now where we're going with this. So we need to go to the symbology, and we need to swap these two bands around, because red, because the normal order is that the red lies closest to the near infrared, so we're out towards the other band numbers, is actually band number 3 in this. And the blue band there is band number 1. Now, even so, now when we, let's just quickly show that works. Yeah, that looks a lot more sensible, doesn't it? It's lower resolution, but we get the right colors. And remember, though, that those band numbers aren't correct, strictly speaking, when referencing Sentinel-2 data. Everything's been shifted along one, because what we don't have is this band 1 data. It's low resolution, spatial resolution. It doesn't contain anything of interest for us, really. It's used for pre-processing, to measure the atmosphere, the interference from the atmosphere, basically. There are other things happening as well, but we're going to ignore this one. So our band 1 in our image is actually band 2, and everything else has just been shifted along. So we need to bear that in mind when we're working with this. Not terribly much, because the computer is going to do most of the work for us. But let's just pretend that we're thinking about it at least. So we've looked at the metadata. We know we're going to do this classification. So how do we do it? Well, the first thing to do, let's just zoom out to the whole image. We can turn that thing off. Now, with that active, what we want to do, that active, we want to go to the classification wizard. And we'll do that in the next video.